Welcome to everyone. Previous class we were practicing that group theory, means point groups and what are the elements. So today class we will discuss about symmetry operations. Symmetry operations. So we already discussed about of symmetry element and symmetry operations. Today we will discuss about of that symmetry operations associated with the point groups. So what I mean, let's say we are going to discuss today. Let's say any C2B point groups. Here the symmetry elements are E C2 plus 2 sigma B. But whenever so this is the axis and here this is x-axis where is to take, this is y-axis, then I take in the 3D system, then I have to take another axis, that is z-axis. So in x, y, z axis, that this rotations is along which axis, that we have to look. Means we today basically the class will be the directions of that rotations, means on which axis we are doing the rotation or which axis we are applying the mirror plane. So if I say this will, so this is for water, let's say water H like this H, suppose this is H1 if I do, and if I H2, then that I have to do the C2 axis, but in which directions? So this is y-axis, this is x-axis, this is z-axis. It means that let's say this is any water molecules, this is any water molecules. If I say this is any water molecules, then that our axis is one is along x-axis. Let's say this is, if I talk, this is water molecules, then one is our x-axis is this direction. So this, let's say these are the three axes. It means one is, this is x-axis, this is y-axis, and one is towards you, this is z-axis, this is y-axis, and this is x-axis. So this is the our three axes. Okay, so these are our three axes. So if I have the water molecules, then this water molecules, so let's say this is the water molecules. So these three axes, one is, all are perpendicular to each other. See, this is perpendicular, this is perpendicular, and these are perpendicular, means all are in the perpendicular. So here it is not looks like perpendicular, but all the axes x, y, z, all axes are perpendicular to each other. So let's say this is the water molecules. If this is the water molecules, then I have to rotate in which axis? This is the water molecules, and if I put this water molecules, it's like this, then that okay, this is the what, let's say this is y-axis, and let's say this is x-axis. So water molecule is a planar, so it will put like this. Okay, so if I put like this, then you can see here that this water molecules, this is x, y, z axis, and all are perpendicular to each other. So this is perpendicular 90 degree, and this is 90 degree, and this is also 90 degree, means all between all the axes the angle is 90 degree. It means all angles are perpendicular to each other. So if this is the water molecules, then the y-axis to y-axis, so if this is the water molecules, one y-axis is this directions, and x-axis is this direction, and z-axis is this directions. So this is the planar, means xy plane, this water is there, because this is y and this is x and this is z. So water molecules, since this is a planar, so this is lie in xy axis. So if I rotate through this water molecules through y direction, if I pass, so and you know that whenever we say that about of axis means any imaginary lines, means axis we can draw like this. This is the axis, any imaginary axis. Whenever we are talking about a plane, we will draw like this or like this, or you can simply draw one line. This is say any imaginary planes, imaginary plane. Okay, so now if I pass the axis here, then I will pass one axis. This axis is C2, so this axis I am passing through, because y-axis is this directions. This is a y-axis, this axis, this is x-axis. So I am passing the planes through y-axis. So this is C2y. Okay, and I have also two sigma b's. So I will write one sigma b, another sigma b. Okay, let's say. So this sigma, let's say sigma I will write. So this sigma, so one sigma, so in the water molecules, let's say if I talk about water molecules here. The water molecules, so one axis we know that is passing through oxygens and reflecting this H1 and H2. So this axis is passing through which planes? This is that if this is the water molecules, then let me if anything there. Let's say if this is the water molecules, and we have the planes, this is the water molecules and we have the planes. So one plane is cutting all this. This is oxygen, this is hydrogen, this is hydrogen. One plane is cutting oxygen and means whole atoms, that is molecular planes. Another is cutting this, only cutting through oxygens and reflecting this and this, and other is cutting all the atoms, oxygen and two hydrogens. So if I say about of that, this is x-axis, this is y-axis, and this is x-axis, y-axis and x-axis, and this is z-axis. Let's say this is x-axis and this is y-axis. So the planes, this is x-axis and this is y-axis. See, this all are, so this is y-axis, this is x-axis. So one plane is cutting through xy, means xy directions, then that is cutting all the atoms, water molecules, that is molecular plane. Another is cutting through only this y-axis. Another is z-axis is towards in the front, so another is cutting through y and z axis. Okay, so if I search, if I search, one plane is cutting, so here this is y axis, this is x axis, and this is z axis. So this plane is cutting through y and z axis. So if this plane is one plane is let's say this is water, so one y axis is this directions and x axis is like this and z axis is like this. So one plane is cutting through y and z axis. So this is plane is y and z axis, this plane is y and z axis. So here I will say y z. Another is cutting through all the planes, molecular planes. So this and these are in the planes, so x and y are plane, so that plane is sigma x y. So two planes are there, one is this planes, this plane is sigma yz, another planes that is cutting through whole planes, so this plane is sigma yx or xy. Okay, so two planes are there, one is sigma yz, another is sigma xy, this is yz. So two planes, and this C2 is along y directions, this is C2 y. So these planes are, so these symmetry operations are present in C2 y if you mention the directions of the axis or planes. So these directions, the element operations are there. Okay, so now what I'll do, water molecules. So here this plane is along sigma because we are taking this. So this axis we can take, here I am taking x and y. So we can take any direction because all are same. Also we can take this. So any axis we can take, according to that name will comes. Okay, so I am taking x, y and z. So according to that my planar will come. So here this means here and there this plane is along, this is along, this means one is in the plane, another is coming towards us, z axis is coming towards us, and y is in plane, and x and y is in plane, and z is coming towards us. Okay, so the plane I am cutting, that is passing through towards us and x axis, sorry, and z axis. So towards us and x axis. Okay, this is x z axis. Another planes I am cutting, this is in the plane, xy is in the plane. So another plane I am cutting, that is in the plane, that is sigma xy. Okay, so now what we will do is that, let's say we have that x, y and z axis. Now you apply that C2 y, then what will the results will come. So whenever we apply that C2 y, then here I am passing that, this is water molecules H1 and this is H2. So I am passing now to C2y, C2y this direction. So this is not our plans, I did something wrong. This is x axis and this is y. Okay, so likewise then this is, I made it in. So this is xy direction, this is z and y, z is towards us, so this plane is towards us and y direction, and xy is in plane. Okay, so one plane I am cutting towards us, this is towards us and y direction, so this is sigma y and z. Okay, so this is cutting so that this and this get reflected. Another is passing through whole atoms, that is, since this is the plane, so I am passing the plane uh, uh, plane which is xy, so this is in the xy is in plane, so I am cutting all the atoms, so I am molecular plane I am cutting, so that is sigma, this is xy, this is in the plane, so sigma xy, so two axes are present. Now if I talk about of that if I talk about of axis here, then let's, this is y axis, so I will cut that C2 y axis, I'm passing the C2 along y axis, then what happens, this y is in the plane, so this will be get interchange, h1 go to h1, this will if I pass this, then this will get interchange, this will be h2 and this will be h1, and this will go to the back. Yes, so now what I say that whenever if I apply the C2 to xyz, this is like xyz axis, xy and z axis, if I do the C2y, then what things will change? You see that in this plane C2y, if I apply, then this y axis will remain constant, and this x will, means let's say this is x and this is y and this is z, and here if you go this, so this is 0 and this is minus x, and this is 0, then this is minus y, similarly here this will be minus z. So if I applying the axis, I am applying through cy, means through the y axis, then but that this x will go here, apply that, and this z will go here, means they will interchange. I am applying that and I rotating by 180 degree, then what happens, this will go here and this will go here. Let me show you. If this and this one, okay, now if I pass a planes and I will do 180 degree, then what happened, that this will look like this will go 180 degree. I'm rotating, means this will come here 180 degree. Okay, then what will happen, this we can see that here this was this red was here, that will go to here, and this was front, this will come back. You see that 180 degree rotation, 90 180 degree rotations. You see that this will come to the front, come to the back, which was initially front, come back, and this will that is right, that will go to went to left. Okay, so that will change, means this directions will go here, this will go here, and if we say that x-axis this side you are taking positive and this side you are taking negative, means whenever this is go to this left sides we take as negative, and whenever this is front side we are taking positive, and whenever it come to negative side, this is taking negative. So after C2y, but this axis remain as it is, because I am rotating through it. Whenever I'm rotating through it, this and this are changing, but this is not changing. Okay, let's say 180 degree I rotate, this is this side, come to back, this will this side, come to this side. You see 180 degree rotations. Okay, but this axis remain as it is, because I am rotating through this axis. So what happened, that this y axis remain unchanged, and this is going back side, and whenever I'm taking this as back side, this is going to be negative, and whenever this is coming to front side, this is going to be negative. Okay, so this y is remain unchanged, so x is getting minus x, y is remain as it is because I am operating through y, and this is minus z. So this is happening. Yes. And similarly now, if you pass that, now I apply c to y. Now if I do that axis, let's say this directions, then if I do 180-degree rotations, then what happens, this will go to back side and this will go to below side, means this will remain as it is. Okay, so let me do, this will go here like this. Okay, this is remain as it is, this was initially front, this will come to the back, but this remain as it is. You see, this is here after rotation 180 degree also, this is as it here, only this is going to back and this is going to above, then this is going to below. You see, this is going to get below. Okay, so likewise, if you apply c to y, c to x, c to z, whichever axis we are applying y, then y will remain unchanged, other will be changed. Similarly, if I apply c to x, similarly if you apply c to x, y, z, then x will remain as it is, it will change. Okay, so similarly so z will remain as it is because we are applying z axis. Okay, so this is about of the axis. So similarly, if you talk about a plane, then so if you talk about of the plane, then let's say this is x-axis, this is y-axis, this is z-axis, and this is 0, and if you go to this, then we are getting minus z, and if you come here, then we are getting minus y, and if you go here, we are getting minus x. And if it is a water molecules, let's say, so if you apply that, we are discussing about of that changes. Okay, so now let me apply that, I will erase it. We are discussing about of that, how this changing. So let's say sigma, let's say xy, or it's better to mention any molecules h1 and h2. Okay, and we are taking these directions. Now if I apply any these molecules, so this is, let's say, sigma yz. So if you do the sigma yz, this will get interchange. Okay, so this is, now the thing is that now what I'm going to discuss is, whenever you are applying that sigma with yz, and if you have x, y and z, then what things will be changed. So you see that here, what that in these molecules, yz is, y is above side and z is front sides. Okay, y is above and z is front. Okay. So now if if any molecules is there, and if you applying the plane in these directions, plane is you are applying in these directions, then here water molecules is there, water molecules, that is like this water molecule is there, like this. So like this water molecules. Now if you applying these planes, this yz directions, means plane is like this. You see, the plane is like this. So if you are applying the plane along this yz directions, that is same as this. This we are applying this one, and water molecules is this directions. Okay, so water molecules is this directions. So if I apply the this yx plane, sorry, yz planes, then what happened that this and this get reflected. So during this yz planes, which axis will change? So here if you look it, then what we say that this get reflected, that's fine, and you see that whatever the axis present, say this is y and z, this will remain as it, because this reflected this and this, and what the axis which is in x-axis, that get inverted. How I search, let's say if I apply these directions, then this is cutting the y and z axis, and x-axis is here, so this will get reflected to this directions. So if they are applying this and water molecules here, this is plane you are applied here, so this and this is contain this plane, but that x-axis is in these directions. So whenever this plane is applied, then the mirror image will come back sides, and y and z are already contained in the plane. So plane already cutting this x and this y and z axis. So this y and z axis already contained in the plane, so this will not change because this is already contained. The x-axis is not contained, so that will get the mirror image. Means if it is here, then that will go to the back sides. And these are, since this is already contained in the plane, this will not get changed. Okay, so whenever you apply these planes CYZ, so these planes contain, this is the plane like this, this is the plane like this. So and this already contained in the plane, so y and z axis. So this is not contained, so this will get reflected to back. So only which will change? X will change. Which is contained, that will not change. So which things will change? X will only change, because this already contains. So how it will reflect it? Because this is already in the plane. Because we also discussed that which the molecules cut the axis, means whenever the plane you are passing, whatever the molecules it contain, that will unchanged, other will get reflected. That we discuss. Similarly, where that x and y axis, if the plane contain y and z axis, then this, since plane contains y and z axis, this will not change. Since this get reflected, because plane is here, so this will be reflected to this direction. So only x will change the sign, and whatever the content in the plane, that will remain as it is, because that is content in the molecules, because plane is passing through this y and z axis, so this will not change. Okay, so why will not change, I already discussed, because that is content in the molecules. So similarly, where we can discuss, like if sigma xz is there, so now sigma xz, the plane is this directions, then y is above directions, so y will get reflected to back, and whatever the molecules contains in this x and y directions, so this is x and this is y, this is x. Now if y, x and z, okay, so this is x and this is z, this is x and this is front to you z, then this will not get reflected, y is above, this will get to back. Okay, so if you pass the planes sigma xz, and if you have x, y, z, then this xz will remain as it is, and y will get reflected back, and that will be, since the back side that is minus y, so that's why I put minus. And since x and z contain in the plane, so that is not reflected. Okay, so this is about of that axis of symmetry and plane of symmetry, how that axes are changing. Okay, now if I talk about of that center of symmetry, Center of symmetry means, like if we say that any molecules, if we have that H, means that in center of symmetry all the axes get change. Means let's say if I apply to x, y, z, then this will every will change, so that will minus x, minus y, and minus z, because it will be the axis which inverted all the coordinates. Okay, just a minute. So for if we apply that I center of symmetry, then that all will get inverted. Okay, now we will discuss that how the relations between this. Let's say if I put that C2y, so this I am taking this is y axis, this is x axis, and this is z axis. Okay, so now if I put this C2y, this is y, this is x, and this is z. So now if I put that any axis I am passing C2y along y axis, and I have x, y, z. So, or I can say, let's discuss a little bit more. Like I will say that C2y I am passing, and I do sigma xz to x, y, z. Then what I will got? So this C2y. So if y is there, then what? That this will not change. Other things will change. So whenever that axis if you pass, so what I understand from above, that whenever if you pass the axis means here only the C2. Other cases is not applicable. Sorry. On that case, one coordinates, let's say it may be x or it may be y, one coordinate, or I can say simply one axis not change. So whenever pass the axis C2, mainly here C2, not valid for C3, C4, it is only valid for C2. Okay, so whenever if I pass the C2, then one axis not change, and whenever if I pass the plane any sigma, then two axes not change, because plane contains two axes, so that will not change. Okay, so now, and we know that here we operate by from right to left. Okay, from right to left we will operate. So first I will operate C2y, then only pass this, then only after that I apply this, second this. Okay, so what C2y, then what, that only one axis will not change, that is along this y axis. So this will minus x, y will not change this. Now this is over. Now this is the sigma xz is there. Now what will the result? So xz will remain as it is and y will change. So x and z remain as it is and y will change. It means minus x, minus y, and minus z. It means that minus x will minus x remain as it is and z remain as it is, and this will get changed. So here plus y, it become minus y. It means all coordinates are get negative. Means how we get this operation by single. So this is from here we are doing. So if you do the operations like this, then we get this. So by single operations, how we'll do? If we apply that I. So if we apply I, this will inverted all this. It will become minus x, it will become minus y, it will become minus z. Okay. Also, we can discuss more. Let's say C2z is there and sigma xz is there. Let's say this is x, y, z. So how will do? First you will do this, then what you will get? Xz will remain as it is and y will get changed. So x, this will change and xz remain as it is, and now C2z is there. Now apply there C2z, then what? The z remain as it is, remaining will change. So this is minus x, this will become y, and z remain as it is. Okay. This is minus, this is x change, and this is also change, plus minus y to plus y, and z remain as it is. So which axis it is? So this x, which we get that from here 1 is changing. It means I will pass. So 2 remains, 1 is changing. So which axis I will pass? This axis, if I pass, I get this here x, y, and z. If I do this, I will get this. So other way, how can I get that? I from here only 1 will change and 2 remain as it is. Means I have to pass a plane. Okay, plane. If I pass c, y, z, then y, z will remain as it, minus x will change. Okay. So it means that what I said from here, that sigma yz is equal to C2z into sigma xz, because if you operate these two operations to x, y, z, we will get this one. Also, if you direct operate this operation, also we get the same operations. It means this and these operations are equal. Okay. So what we remember that not if 2x's, or I will write middle, if 2x's are changing, if 2x's are changing, then I will look for axis, and if one axis is changing, then I will look for plane. So here you see that from here only 1 is changing, so 2 is remain unchanged. So I will look for plane. Okay, because for plane 2 things are contained and that will remain unchanged. So if 2 is remaining unchanging, then I will, this way also you can say, or you can also say that if 2 axes are unchanging, then we will look for plane, and if one axis is changing, sorry, unchanging, we look for axis. Okay, so from here that how many axes are changing? One axis only changing, so we will look for one axis changing, look for plane. Or if 2 axes are unchanging, then we also look for plane. So we will look, this is a very common things, like it contains this plane, means this will not change. So other than this, whatever other than the axis which is not contained in the plane, that will only get changed. Okay, Also you can shortcut, like if you directly you want to apply, then also you can that if two axes are changing, then it has to be axis, and if one axis only changing, then it has to be a plane. Or if the two axes are unchanging, then it has to be a plane, and if one axis are unchanging, then it has to be a axis. Okay, I am saying that this whenever we will study that, we will study now that multiplications of whenever making the group tables, on that times this will needed to make the point group. Okay, so another examples you can look that if is there like S4 is there, and let's say this is z axis, and we have that sigma xy, then what is, so this is equal to which value? Okay, let's say, so we know that this is equal to x y z. So what it will look, so see that S4 z, or S4 means, or I say that Sn is, that is Cn, or I can say that Cn perpendicular to sigma h, or I can say any Cn perpendicular to sigma h, or any sigma h into Cn. This will give the Sn value. Okay, so now what I will do, so this we know, so I will just erase it so that I will write it. So this S4Z means let's say sigma h into C4. This is what mean by S4. Okay, so now that this, since this S4 is along Z axis, so if this is the axis and S4 means C4, and this is some Z axis, if I say, sorry, if I say this is along Z axis, so this is X, this is Y, and this is Z. Okay, so if it is along Z axis, if C4 is along Z axis, then this axis, the perpendicular sigma h, for this axis the perpendicular plane will be this one. Okay, for this the perpendicular plane is this one, and it cannot be like if you say that this is y, this is x, this is z. So for this, if that C4Z is this directions, then the plane cannot be this direction, because this and this will be not perpendicular, this plane and this one, because this C4Z contains this Z axis. So for this, if the axis is along Z axis, then the plane has to be XY plane. Okay, has to be XY plane. So this I have to clear that. Like if I search, if that suppose that axis is passing through these directions, then here to this, that plane perpendicular to this axis, because S4 is C4 perpendicular to sigma h, and suppose C4 is coming here, then sigma h has to be perpendicular, that has to be this direction, that cannot be this directions, cannot be this directions, or cannot be this directions, it has to be this directions, so that this and this get perpendicular, this and this get perpendicular. Okay, so this has to be, if that C4 is Z, then that plane has to be sigma xy. Okay, so if I write here, then I can write this one. Let me take. So this is sigma xy, and this S4 I can write that C4Z. Then this has to be, if this is coming, then the plane has to be sigma xy, and sigma xz or sigma yz cannot be, because they are not perpendicular to C4Z. Because for S4, C4Z and sigma h has to be perpendicular. Okay, so this cannot be. Okay, so only this plane is possible. Okay, now what I will do, I will erase it. So here if I do that, then this is xy, this is xy. Okay, so this sigma xy into sigma xy, that is gives into C4Z, and this same molecules will give rise to E, and that is C4Z, and that is become C4Z, because sigma xy and sigma xy, the same planes. One is sigma xy, x and y, another is xy. If we multiply these two, then we will get the value E. Okay, so that will going to give, so whenever the same value if you multiply, then we get the E. Okay, so this is going to be C4Z value. So this value is equal to, we can say, C4Z. And similarly, if I practice, let's practice one more. If you do that, sigma xz into, let's say, S4, that I will talk, let's say S2 z. On this times what will happen, that, and we will say xy z. What will that sigma xz, and this means that C2z into this, if this is z axis, if it is along z axis, then the plane has to be, this is z axis, then the plane has to be, this is z axis, the plane has to be this direction, so that this and this get perpendicular, so that has to be along sigma xy. So now this and this get different. Okay, so now sigma xz into sigma xy to C2z. So what the value will comes if we multiply by this two difference? Okay, so because rule is you have to follow by this direction set, right? So sigma xz, on that case, since they are same, that's why I take it at one place and I put that E. But now this is different, so I have to proceed like this direction, because operations will done from right to left. Okay, so now sigma xz is there and C2z is there into sigma xy is there here, x, y and z. So if I operate these things, then xy will remain unchanged and z will change, so x, y minus z, and now C2z, this is I already operated, and sigma xz. Now if I operate this one, then z will remain unchanged, other will change, so this will become minus x, minus y, and this is minus z, and now sigma xz. So now xz will remain as it is and it will change, so this is minus x, this is y, and this is minus z. Okay, so this is equal to which axis? If I pass C2y x, y, z, I will get this value, because C2y, y will remain unchanged and this will get negative. Okay, so this is equal to this axis. So likewise we can do the other operations, we can practice. So next we will move on making that like point how to make the group table. Okay, so let's search for C2B. So that things we're supposed to do group multiplication tables. I think anything left? So we will now do the group multiplication tables. So now we will discuss about a group multiplications table. Okay, so we will discuss first with C2B molecules only. So C2B, it has the C2B, so water molecules you will take because it is just to do. So I take water molecules and I'm taking the axis. This is y-axis, this is x-axis, and this is z-axis. Okay, so that I apply the two here. One plane is there. This is yellow y and z. This is sigma y z, and another planes we have, that is cutting all molecules, molecular plane, that is this is along y and x, planar y and x, or you can say xy, and we have that one axis, that is say C2 axis. So this C2 axis is along C2y. Okay, so these are the symmetry elements we have, or symmetry operations we have. So if we make the group tables, so in the C2B, what are there? One is C2 along y-axis, first is E is there, and C2y, then we have that sigma yz, and we have that sigma xy. Okay, so we will make the table. So here C2B, so one is E, another is C2y, sigma yz, and sigma xy. And similarly I will do here also. I will do E, same things I will repeat, C2y, sigma yz, and sigma xy. Okay, now I will multiply this E and E. So if I multiply E, then we will get E, and if I multiplied by this first E and E, after that E and this, then again I will get C2y, because E anything will give the same, means E into C2y, this is identity element, I will get the same value. Similarly if I multiply by this, again I will get this value. Similarly if I multiply this, again I will get this value. Okay, now similarly if I next this one I have to multiply by this, so I will get again this value. And if I multiply by this and this and this values, okay, so for this value what I have discussed, we have to multiply by this to get this, and you have multiply by this to get here, that is sigma yz, and we have to multiply by this to get this value. Okay, for here we have to multiply by this, for here we have to multiply by this. So everywhere if we multiply by E, then we get the same value. Okay, so this is very clear, because if you multiply by E with any value, you will get the same value. So we know that for group, that the POR condition that has to satisfy that it has one elements E which commute with all the elements, which after multiplying this value we get the same value. So that should be have for a group to be a point group. Okay, so E is there, so you have to get the same values like E, C2, sigma, yz. So we are multiplying by E with this means we are multiplying by E with this, so we will get the same values. Okay, now again here what we have multiplying by this with and this with this value with this, that's why you get it, and this value we multiply by this, that's why you get it, and this value we multiply by this, that's why you get it, and this value we multiply by this, that's why you get it. So if we multiply by E, then we get the same value like this. Here and here we will get the same values. Okay, now the thing is that next, so I will erase it. It messed up. So C2 we have E, C2y and CYZ and CXY, CYZ and CXY, and similarly value here also. So here also we will do E, C2y, CYZ and CXY. So this value will get same, we have explained already. This will become E, this will become C2y, and this will become CYZ, this one CXY, so sigma xy, and this will again same C2y. Okay, why? Because this multiplied by E, then we will get the same value. Okay, now next, so for getting this value we have to multiply this with this. So if the same value like C2y multiplied by C2y, then we always get the E. Okay, similarly if we multiplied by sigma xy into sigma xy, then we will get always E. Okay, similarly if we CYZ, we get the value E. So if we multiplied by E and E, then we will get the same value. So I multiplied by this and this and this to get this value, and I have to multiply it for getting these values, which I have to multiply this one to get this value. I have to multiply this one and this one, and to get this value I have to multiply this and this one. So for this value we have to multiply this and this one. So let's say C2, I'll do here C2y into C2y into C2y. So we will get the E value. So here E will come. Okay, because same value. Now to get this value I have to multiply C2y. So multiplication starts from here. So let's say C2y into this one, for getting this one, C2y into sigma yz. Okay, so what I apply? XYZ we apply. So this value give that y is remain change is minus x y z, and after that sigma yz is there. Okay, now we apply this one. So yz remain as it is, y and z remain as it is, then this will become x y z. So this value how we will get? That I have to 2 remains unchanged, means I have to pass a plane, that is sigma xy. So this value we will get sigma xy. Okay, so now here to get this value I have to multiply this with this. So I have to multiply sigma xy into c2y into c2y. So you put x, y, z. So here what you will get, x and y remain as it is. So x, y, and this will change, and c2y. c2y means y remain as it is, 2 will change, that is minus x, y, and this will become change, minus z to z. Okay, so this value will get how? The 2 are remaining on each means sigma yz. So this value will get by sigma yz. Okay, so if you notice carefully, then what we see that whatever the symmetry operations are there, like this symmetry operation, this symmetry operation, this symmetry operation, this symmetry operation, this is same symmetry operations are repeated here. See, this is came again this value, this came again this value, this came again this value, this came again this value, means the same value will repeated, means whatever the symmetry operations are there, the same operations will come here. Which position will come, that we will decide, but nothing other than this symmetry operations will not come. Whatever the operations will come from this 4, any of this 4 will come here. And we know that E where will come. If the same will multiply, then E will come. We know that if same will multiply, then E will come. Okay. So here that E will come because same will multiply. Similarly, here E will come because wherever the same things will multiply, E will come. That we know. Okay. So this value we know. Now only the remaining is, we don't know the value, which value will come here, which value will come here, which value will come here, and which value will come here. Okay, so this how we'll do that. First thing, that the same elements, these 4 elements only will come, other than these 4 elements nothing from outside, that will not come. And if we multiply the same things, E will come. That's why here I multiplied by this and this, EH came. Here I multiply by this and this, EH came. Okay, so this and this, for that we have to see. So what we look, that we look here, for this value we have to multiply this, and for this value you have to multiply this and this, cyz and c2y you have to multiply. Okay, so cyz and c2y for getting this value. So you see that yz is already there, and the value will not repeated. See, yz, xy, e, so c2y, the value is not repeated. Okay, so once yz has came, then yz will not come. Okay, this will not come, and remaining is either this will come and this will come. Okay, in between this anyone will come. And whenever so yz and c2y, so which should come for this first we will do, after that we will look the trick more. So let's say, okay, cyz into c2y. So here x, y, z. Okay, so c2y means this minus x, this will z. After that c, y, z, then y and z remain as it is, then this is minus x, this will become plus x, and this is y, this is minus z. Okay, so this will come that sigma xy. Yes, so here sigma xy will come. It means that whenever we multiply another things, that if we multiply sigma and x's, then sigma will come, and if we multiply it by 2 sigma, then here c2 will come. Okay, so in this case same, so in this case different, then here c2 will come. Okay, so that we will see that all are different. Okay, so similarly if xy, here this has come, and this So if one is axis, another is one is plane and axis, then always what will come? Sigma will come. And other than that, that is sigma xy is already there. Then not come is yz. So I will write yz. And now this for this and this I have to multiply. Whenever I multiply two plane, then axis will come. Okay, so this is the axis C2y. Okay, so these are the things. So the group multiplication tables, while you doing that, these things you have to remember. So you can check that whether it is correct or wrong by doing multiplications by taking x, y, z axis. So trick is that, not trick, this is you have to do always. So that only the group operations, only the operations which are present same things will come. I mean nothing from outside of the symmetry operation. What are the symmetry operation are there? Outside of the operations for that particular point group. Okay, this is one. So means this same things will come, whatever that this or this any things from this 4 will come here, nothing from outside from that. Okay, that's what I mean here. And secondly, what that no repetitions. No repetitions is allowed. Sorry for it, correction if spelling is wrong. No repetitions is allowed. Means the group will come once. The operations will come once in row as well as in column. We can see that here the no repetitions, only one time it came. Okay, here also no repetitions, similarly here also no repetitions. Okay, and third things we have to remember, that is if we multiplied by like same like sigma xy into sigma xy, then always we get e, like c2y into c2y, that we will get e, like that. If same will multiply, then we will get the e. Okay, and for saying that if we multiplied by sigma into any sigma, I will write, if we multiply by sigma into sigma, then we will get the axis. We will get the axis. And if we multiplied sigma into axis, then we will get the sigma. Okay, so these four things if we observe, then we can make that group tables very quickly. Okay, so likewise here if I multiplied by this and this, then what I will get? Sigma has come. Okay, because if I multiplied, and if I multiplied by this same and this, then let's say this and this, if I multiplied, then I will get the c2y. Okay, so these four things, just look carefully that if the two operations which are present, the same things will come, nothing from outside, and if the operations will come once in rows as well as in columns, that will not repeat it. And if the same things will multiply, then we will get e. And if we multiply by this sigma and sigma, then cn will get, and sigma and cn if we multiply, then we get the sigma. Okay, so after making that group tables, so let's forward to what we'll do. Now we look an order of point groups. So next topic is order of the point groups. Order of point group. So order of point group, it means that the total number of operations needed to get the identity elements for any symmetry elements. Let's say if you talk about of that any C2 axis, so let's talk about of the Cn axis. If I talk about of that any Cn axis, then let's say about of C2, then this is water molecules. We can take water molecules. Then here if I apply that C2, then what is it? H1, and this and these are identical. Now again if I apply this is C2 1 and again apply C2 2, then what will get? So these and these are identical. So how many operations I needed to get this value? So this is 1, this is 2, so this is 1 operations I do, this is 2 operations, then I get the identical operation. So if we talk about of that for C2 axis, sorry, for C2 axis, number of operations needed to identical is 2. Okay, because here that we including the identity. Okay, that if excluded identity, then we get only 1 operations because these and these are identical. But if not asked, but it says that specifically for C2 axis, then we need the 2 operations to get identical orientations. So order of point groups, that is represented by H. So this is actually that total number of operations needed to get identical orientations of the molecules. Okay, so here for C2 axis, how many operations? So H equal to 2, that is order of the group, or that order is represented by H. So here that is 2. Okay, similarly for if I talk about of that sigma plane, then for that say, so here if I say that H1 and H2, then if I apply that sigma, then what happened, that H1 and if I, that is again, if I apply that again sigma, this is sigma 1 and sigma 2, again the same sigma we have to apply, then what we get, that same value I will get. These and these are identical. So how many operations I needed to get identical? This is identical. So how many? That H is I needed 2. Okay, so similarly if I go for, so you may think that this is this molecule, another plane also there here, let's say that is plane passing through all the atoms. On that case, what will become? This H1 H2, but this will go here also, this is back sides, right? And again operation this will get. Now here what back sides? This is equivalent orientations because this is in the back side. Okay, now again if I apply that same planes, then I will get in front. The total number of operations are again 2. Okay, identical means same things. Here that is back side has gone, so this is equivalent, not identical. Okay, this is equivalent because this is back, this is back. Similarly here this is back side. You see that if you look at that these molecules, here if I look at that Is it visible or not? Okay, it is not visible. So okay, I can do that. So this is the water molecules. Now if I pass that one planes, let's say let's say here that my pen, like my finger is here also my finger is here. Okay, now if I did that C2 axis, what I think one thing wrong. Okay, if I pass the molecular plane, here is that, then this will get the back side, means here if I this my finger, it will get back side, that will become like this, like this, like this. Now my fingers will go to the back sides. Okay, so this is not identical, this is equivalent. Okay, because previously my finger was in the front sides, so we can understand like this. So here that will not back sides, sorry, this is I passed that two axis. So whenever we pass it, then this H2 and H1, this get replaced, and this is in the front itself. Again if we pass, then that will go to again that replace, but here this will be going back and front. After that this is the identical. So again number of operations is 2 to get identical. Okay, similarly if I look for I, center of symmetry, so we have that symmetry elements. One is Cn, another is sigma, another is I, another is Sn. Okay, so Cn we cover, sigma now is I. So for I case, let's say this type of molecules. So here if we go this type what molecules, here if molecules. So if I operate the I, then let's say this is H1, H2, and this is let's say H3, this is let's say H4. So what we will get? So this is become H2 and this is become H1 because inverted. Okay, so this is become Cl3 and this is become Cl4. Again if I apply again I, then again this will get inverted. So this is again we going to H1 to H2, this is again going to Cl3, this is again going to Cl4. So this and these are identical. So how many operations I have did? 2 operations. So here also order of the group is 2, or no, order of this seat I is how much? 2. Okay, so if this is all where that I am including the identity. If I exclude the identity, then H is equal to 1 because this is the identity. Okay, so if you include the identity, then H equal to 2. Similarly for Sn axis, we have already discussed that when n equal to odd, then number of operations needed is n minus 1 operation is needed. Let's say if S28, for this number of operations needed to get identical is 27. Okay, that is n minus 1. Sorry, this is odd, that is needed 29 minus 1, 28 operations is needed. And if n equal to even, then this is H. So number of operations needed is n up by n upon 2. So if S28, then number of operations needed is 28 upon 2, that is 14. So H needed is 14 if that we have the Sn axis. So if we look all these things, then what we see that, so we have to note that whenever Cn axis is there, then a number of operations needed is n minus 1, that is needed is n operations is needed. Okay, now I am not excluding, I am including that if, here it is important to note that if specifically asks that a number of operations of the axis, of the specific axis. Okay, on that case, if Cn is there, then number of operations needed are n, and if I, the number of operations is 2, and if sigma, number of operations is 2. Okay, and similarly for Sn, then if n equal to even, then n upon 2, and n equal to odd, then n minus 1. So please note that I am confused about of it, but this is correct, and this is correct, this is correct, this is correct. Okay, so this is if specifically asks for the number of operations of the axis. Now if in the point group, if the group is there, like says C2b, here the axes are E, C2 or C2, that may be Y, and sigma xy and sigma yz. Okay, so whatever that groups, it's better to write. So it can be very like if what axis you are taking, x, y, z. So if you are taking which axis, like that name will come. So I am writing generally, like if E is there, E plus C2 is there, plus sigma is there, plus sigma is there. So for this case, number of operations, how many? So for E, we have already written that E, for E, 1 operation is needed. So C2, for C2, 2 operations are needed, but here C2, if we talk about water, whenever I apply C2, then it's going to become H1 and H2, and H1, and now again if I apply C2, then I'm getting the same one. So this is identical. So if the specifically, then this is 1 and this is 2, but in the group it asks, then already E has included, so I will not include this. So I only take only 1. Okay, so C2 is whatever the value is there, I will do that. I will do a little bit E, then operations is 1, the number of operations needed. Okay, and for C2, then that is 2 minus 1, that 1 is excluding this E, but because E was present, that's why I subtract E. E is 1, that's why I put E. Okay, similarly sigma, that is 2 is needed, I will again subtract 1. Again another sigma, again I will subtract 2 minus 1, because here also E was there, that's why I am subtracting, because E already included. So in the group, then that will subtract 1 for C2 and sigma and I. Okay, so here the number of operations needed are, this is going to be 1, 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 so total is 4. So now order of the group of C2b is 4. Okay, similarly if sigma is there, if I is also there, then also that will be 2 minus 1, because I is subtracted, because E is already included if it is in the group, and if it specifically asks for I only, then it will be 2. Okay, so if you normalize it, then if any Cn axis is there in group, so I normalize it in group. If Cn axis is there, then number of operations will be n minus 1, and sigma then 1, and I is there, then 1. Okay, and if specifically it says then Cn is n, that is number of operations, and sigma is 2 and I is 2. Okay, so we will look that like C2B we have the groups, like if you take about of NH3, so this is like this H. So here that C3B point groups we have already discussed, that is C3 is there, E is there, and C3 is there, and 3 sigma B is there. Okay, so sigma plus sigma. Okay, so here that for E that is 1, and for C3 that is n minus 1, because Cn then n minus 1, so this is 2, and for sigma again 1, another sigma again 1, another sigma another 1, so total is 1 2 3 4 5 6. Okay, so it is like we have that trick to remember, like if I write point group, that is formula, not trick, and here order of the group, that is represented by H. Then if I write one, like if I say that any Cn group is there, then number of order will be n, and if that CND, then order will be 2n, and if CNH, then also order will be 2n, and if DN, then order will be also 2n, and if it is DNH, then order will be 4n, and if DND, order will be again 4n, and if that is CS, then order will be 2, because here that identity and sigma. Okay, for sigma is 1 and identity is 2, so CS 2, because here only E is there, because E on the symmetry, so E is 2. Okay, and identity is included, and C1, here only E is there, that's why 1, and what I'm writing here, one case. Okay, and if we have CSC and CI, on this case only I is present, and for I also how many needed? 2, and now because I is there, for I 2 is needed, one is identity, another is for I. Okay, and if I discuss about of the more that like highly symmetric elements, that is O or TD, how many needed? 24 needed. This you have to remember, actually this 24, and OH we needed 48, and for icosahedron we needed highest, that is 120. So these 3 things actually we have to remember, not trick, to remember, because this is only you have to trick. But for CI, because only one is there, and one from I and one from E, that's why 2. and for C1 only one symmetry element there, E, that's why 1. CS, sigma and E is there, so that is 2. And D and D point groups, because they are more than one C and X are there, that's why they are power n, and DNH and DND power n, and here only one, that's why 2n, same as here 2n, and this is Cn. Okay, so if any group will ask, like say order of the point group, let's say C to B, the order of point group is 2n, so 2n is here 2, so that will be for C3b here, so n is 3, so 6. We have discussed that 6 point groups are there. Okay, so like that we have to remember these things. So although this is very easy, let's say Cn is n, Cnb is 2n, Cnh is 2n, Dn is 2n. All the D will be power n, only that Dn here will be 2n, and the rest 2 DNH will be power n. And or CNH, CNB and CNH are 2n, and CNH n. Okay, so from here the Cn will be that is here 2, here is not 2, here is simply n, here is 2. If NB is there, only n is there, only n. Similarly here DN and DNH, DNH and DND, power n is there, so this is 2n. So for DNH and DND we have to multiply 2. Okay, so simply DN, then DN, and if you multiply it by DNH will come there 2 into 2n. Okay, so we may understand it. So today up to this, thank you.